Okay, here's my second proof example. I parallelogram ABCD with AB extends to P so that CP is perpendicular to AP and DQ is perpendicular to AP. So I'm going to start with my ABCD as a parallelogram. So what I know from my parallelograms is that my opposite sides are going to be congruent and that they're also going to be parallel. I also know that my opposite angles in my parallelogram are going to be congruent. Okay, now I'm going to look at my next fact. CP is perpendicular and DQ is perpendicular. So now I'm going to stare at this picture because what I want to prove is that this is a rectangle. So looking at this picture, I notice that I have triangles and I can see that of the two triangles that I'm looking at, my AQD and my BPC, that I have a hypotenuse here, I have a right angle here, and I have an angle here. I have the hypotenuse and one of the angles on this other triangle, but I want to prove that these two angles are congruent. I can do that because these angles are going to be supplementary. And these angles will also be supplementary, making those congruent. Once I prove that those are congruent, then I can prove that these two sides are congruent. When I do that, I will have two right angles and two congruent sides, which can prove that that's a rectangle. This one's messier, y'all. It's a little bit harder. I would not call this an easy proof by any means, but let's see if you can follow me written. So I have statements and reasons. So first, I'm just gonna list my givens that I have parallelogram ABCD. And in fact, I'm going to show you again on the picture what I did as I go, in case you just got lost in my reasoning. And I know that these are both perpendicular. Okay, so in order to prove that this is a rectangle, what I am focused in on are these two triangles. So I need to prove that these two triangles are congruent so that I can prove that DQ and CP are also congruent. So what I identified first was that DA is congruent to CB. And I was able to do that because I know that that shape is a parallelogram. And that parallelograms have congruent sides. Next, I was able to prove that angle DQA and angle CPB were both right angles. I don't know why I just drew a line over that. And I was able to do that because of my definition of perpendicular. And then we can go ahead and say that those two angles are congruent because of the right angle theorem that says all right angles are congruent. Okay, so I have a side and angles. Next, what I knew because of the definition of perpendicular. Remember, my goal here is to prove that these two angles are congruent. Now, I can do that by saying that angle A is supplementary to angle CBQ. That's from the definition of parallelograms. And then I can say that angle CBP is supplementary to that same CBQ. And I can do that because they're a linear pair. So now I'm able to make the jump to say that angle A is congruent to angle CBP because of the supplementary angles theorem. If two angles are supplementary to the same angle, then they're congruent. So now I have that triangle DAQ is congruent to triangle CBP because of angle, side. Oh, I've run out of room, but we're at almost the last step. There are two more. So after we prove those congruent, I can prove that DQ, I'm going way over here, y'all, is congruent to CP because of that CP-CTC. And finally, because of that, then I can prove that QDCP is a rectangle because of the definition of a rectangle. I have my right angles, I have my congruent sides. Therefore, two right angles, two congruent sides, it's a rectangle. This one was long. Your one you're doing for practice isn't this long. Again, I'm just showing you how this process works. We're stretching our brains this chapter. I don't expect you to do one like this on its own. It's pretty challenging, but there is one that you're doing. It should take you about half of this, about 5 steps, and I have put a hint in the practice. So just attempt it, y'all. Just try, see what you can do so that we can get better at this.